So one of the most powerful things about a least squares regression line is that we can then use it to make predictions about the world, especially connected to the quantitative variables that we have. So looking at a very simple example with pre-test, post-test scores after a SAT prep class. Here is the regression equation obtained from it, from the data, and I'll show you an artist how to do that. If you wanted to do it by hand, it's easy too with the hand calculator or the Desmos calculator. Estimate the post-test score, the Y value, right? This predicted value. Get a prediction. If you know someone scores 75 on the pre-test, could we predict what they would get on the post-test? You use this equation here. You just plug in 75 and replace for X since that was the X value. And you get the prediction. That's it. It's that simple. Now, on the ARTISTAT, this is the way it will look. So back to linear regression, fit linear regression model, our own data, pre-test, post-test. I entered the data, and then you hit submit equation. Pick plot options. I want the regression line. So you hit submit, and there it is. There's the data. We don't have this graph on our notes, but this is the way it looks. There's the data. There's the summary statistics or descriptive statistics for all the values. I look to see the correlation is really strong, 0.95, 92% of the variance can be explained by these variables here within post-test and pre-test. So it's pretty strong connection between them. And then if we wanted to make a prediction, which our case was 75, you click the find predicted value, and then you put 75 in there, and there's your 87.09. You have a predicted for 75, it predicts like 89 right there. You could see it even on the line. I can just do that too. So that's another way to do the prediction there, 75, 87. So we now have a prediction. That's how some of these people make predictions, that when you hear people making predictions in the world. Now we also have something called residuals, which is our observed value minus our observed value minus the predicted value, which we'll see in our notes right now. So if someone scored a 37, right, or let's just go ahead and look at the notes. As we look here, the residuals, right, again, how close is our prediction? That's what our residual tells us. The observed value, the one that we actually have, compared to the predicted value, ROP. And that gets us a residual that tells us how good our estimate is. Closer to 0 means it's almost perfect. Now, in this example, find the residual for a student who scored 37 on a test. Well, the predicted value for 37 is 49.681. We can get that from the ARTISTAT. The observed value is 54. The residual would be 54 minus 49.618, and that's your residual. How far off the value is that number? Is it big or small? Again, it all depends upon your what's the context, what's the variable, how far off is it, right? And then what's the mean? So is that 4 points in this case? You can decide if that's a large error or not. So keep that in mind as we're calculating residuals, okay? And that's the end of this lesson here. And oh, and there's the interpretation.